Yeah, we are looking at the 5 essential rules for integration. And then the first one we want to look into is um, yeah, what the rule is saying is that when you have a sum of finite number is that finite number means they function as an end, okay? Of some of this. So what is saying that you have some of this function, this is that this one plus this one plus this one, all enclosed under integration. What it means is that it means that it will be what? Integral of what? Each of what? Each of the function. It will be what? It will be easy. Finite number of functions, okay, is what is the sum of their what separate integrals. So it will be integral of this plus integral of this and then plus integral of what this. So that what the rule is saying, that when you have integral of sum of finite numbers of functions, it's going to be what? It's going to be sum of their what? Separate integrals. Okay, this is sum of function. We have this one plus this plus this. So under this integration, so it's going to be what? Integral of each of those functions. And this will give us what? X3 over 3. Then plus this will give us integral of sine is minus cos x, and then this will give us what? This will give us this is x half, which will be equal to what? X 3 over 2, and then 2 over 3 plus c. So that's what the rule is saying, that when you have integral of sum of functions, that is going to be integral of each of those functions. So let's see number 2. Example to buttress this. Another example to buttress this is when you have integral of ex minus cos x dx. Here is addition, here is difference of functions. So which will be equal to integral of this minus what? Integral of what? Integral of this. And that will be equal to integral of this is ex. And the integral of this is what? Minus what? Integral of cos is sine x, and then plus c. So when you have difference of functions under integration, it's going to be integration of each of those functions. So that's just the implications of that. That's the implications of that. Number 2 of the rules. For example, you have integral of 6x4 dx. So this is a constant we're talking about. That this constant can be brought outside. Okay, so that will be equal to what? 6 integral x4 dx. It's not a must, it's just to make it work easy. So you can bring the constant outside the integration, and this will be equal to what? 6. Integral of this will be what? So times x5 over 5 then plus c. So that's that. That will give you 6x5 over 5 plus c. But it's not a must, but it's just one of the rules. A factor may be brought outside the what? Integral. Another one to buttress that b part. We have an integral of 5 over u du. So this 5 can take it outside, and that will be 5 integral of what? 1 over u du. And that will be equal to integral of 1 over u. No, 1 over x is ln x. So this will be equal to 5 times ln u plus c, which is 5 ln u plus c. Okay? And you could have it another form. You have 6 cos x minus 4x squared dx. So you can see that this will be equal to, the first one will be equal to, you can take the 6 outside, and that will be cos x dx. Okay, and then minus that one also. The 4 can go outside, 4 integral of what? S squared dx. Okay, but actually this is not compulsory. You do that. It's not compulsory that you do that. Okay, so this will be equal to 6 sin x plus this will be 4 times x3 over 3 plus c. Okay, then the third rule says that look at this integral of cos x plus 3 dx. So what this rule is saying is that the additions of a constant to the variable is x here, and you're adding the constant plus 3 there. It makes no difference to the answer. Okay, don't forget in the standard rules, we are aware that cos x is equal to what? Cos x dx is equal to sin x. Okay, so if you're now adding a constant to that variable, it doesn't change the result. Doesn't change the result. So this will be equal to sine what? Sine x plus 3 and then plus c. So that's what the rule is saying, that when if you're adding a constant, okay, to the variable, okay, it makes no difference to your result. Okay, cos x is what? It's sine x. Cos x plus 3 is also sine x plus 3. So there's no difference to the result. Let's look at more example on that. Yeah, look at this general rule. We are still on the rule 3. If you have, we know for the table x, is that clear? So if you are now adding a constant to this variable, that does not change the answer. It's just what? Ln what? Ln x plus what? Plus a. Doesn't change the answer. So that's what the rule is talking about. Okay. Another one again. Don't forget, we also discussed. We said in standard rule that we have integral of dx over x squared minus probably plus 9, for example. If you have this, so you are expecting arctan what? Arctan x over 3 and then 1 over 3. 1 over your a is what? Your a is 3 or 3 plus c. Okay. So let's now imagine you're adding a constant now to the variable. The variable is x now. You're adding a constant. And the constant you're adding is minus 2 to the variable. Okay. And then plus 9. That's we're adding minus 2 to the variable. And then you square that variable. Okay. Does it change the result? No. So this will be equal to what? Arctan. One of these, x minus 2 over one of these over 3. Then 1 over your a, that's 3. So that's what the rule is saying, that when you're adding variable to the when you're adding a constant to the variable, it doesn't change the form of the result. So number 4, rule number 4, rule 4, rule 4. So this back to this. This is the standard rule. This is the table. This is the law I'm talking about. The rule number 3 we're talking about. Okay. Number 4, multiply. Yeah, what this rule is saying is simple. Look at this. Look at this. Integral of cos 5x. Integral of cos 5x. Integral of cos 5x. Okay, dx. You can see that we are multiplying the variable by what? By 5. For the table, it is we have cos x. Okay, for the table. So when you're now multiplying that variable by variable, okay, by constant, okay, we said it makes no difference to the form of the result, but we must divide by that constant, and that's what we have done here. We must divide our answer by that constant. Okay, let's see another one. Integral of e minus 2x dx. Don't forget, from the table, we are aware that integral of exponential is also exponential. Okay, but when you are now multiplying the power, the exponent of the exponential, the exponent, how will I say it now? When you are multiplying the variable now, look at the variable you have is x, and you're multiplying by what? By minus 2x. Okay. First of all, it makes no difference. We write the answer. That will be what? That will be e minus 2x. But we must divide by that constant, which is what? Minus 2 plus what? Plus c. Must divide by that constant. Okay. Another one again, let's see integral of cos x over 3 dx. Don't forget, in this case now, we are multiplying the constant by 1 over 3. Okay, first thing we must do first, integral of cosine is sine x over 3 plus c. It makes no difference, but we must divide by that constant which we are using to multiply the variable. Okay, and the constant we are using here to multiply the variable is 1 over 3. So we have to divide by that. So that will be equal to what? Divided by what? Divided by over 1 over 3. Okay, and don't forget that there's a visible one here. Okay, so it should become what? 3 sine x over 3 plus c. So that's that on that case. Let's take one more examples on this. If you follow the rules, it makes work easy. Okay. If you don't follow the rules, you get the wrong answer. Okay. All these 5 rules are very crucial. Okay. We've stated now 4, so it remains 1. But before we go to the last one, let's take more examples on this fourth one, on the fourth rules. Can we look at the table? The table says that, the standard table says that we have the x in the brackets, integral of this, possibly it said a squared minus s squared. That's the standard table, which will be equal to what? This is arc sine, one of these over what? Over a. That's plus c. That's the standard rule. But in this case now, you are multiplying what? You're multiplying the variable by what? By 4. You're multiplying the variable by 4. So in that case now, you have to divide over 3 squared minus 2x squared. Okay? The two of them must be multiple. So in this case now, this will be equal to arc sine. What do you have here? 2x over what? Over 3. Okay? Then in plus c. This is the result. But there's an attachment, there's a constant that you have multiplied by the variable. You have multiplied the variable by this constant. That's 2. So you divide by that 2, 1 over 2. And that gives you the answer. Okay? Let me repeat that again. We must express this one in this format. This must be multiple. 2x squared. 2x squared. And then this one must be multiple. This is 9. That's a squared. You can see a squared. That's 3 squared. Okay, and then we take one of these 2x over 3. Okay, and then you now divide by the attachment to that variable. That's 1 over 2. That's by. So that's that. If that is not clear to you, what I mean is this. Arc sine 2x over 3 plus c 1 over 2. 1 over 2 divided by what? By that 2, which is same as what? 1 over 2 by this side. Okay? So next thing we are going to do now, let's apply the third rules and the fourth one. The third and the fourth together. Let's apply the third and the fourth rule together. Okay. To the question below. So let's apply the third and the fourth rules together to the question below. A, integral of 3e integral of e 3x minus 4. Okay, that's 1. 2, b, integral of dx over 2 minus x. And then c, integral of root 5x plus 3 dx. No, I'll put dx there. Dx there. So let's see those 3 questions. Okay, we have one more. Let's see another one. Integral of 1 over 4 minus 3x power 5 dx. Integral of e to 3x minus 4, okay, dx. Anytime you see exponential function, write the question as the answer. That's your first thing to do, plus c. Then the next question is to now what? Look at this one. What is the derivative of this power? That's 3. And then you divide by the derivative. And that's all. Divide by derivative. That's all to that question. The b part, we have integral of dx over 2 minus x. Okay. So what we do to this one is we have to start on here. Don't forget that integral of 1 over x is what? Is ln x plus c. So something is happening here, and we're going to solve that. Yeah, we're going to solve that. Can we take minus out here? Let's take minus out here, which will be equal to, I'll tell you the reason for doing that. If you take minus out, minus into brackets, this will now become what? This will become x, and then minus 2. Okay, let's take minus out there. Okay, the reason we are taking minus out, we want to conform to the standard rule. Okay, we want to conform to the standard rule. So which is now become, you can take this one outside the integration, which will be minus into brackets d dx over x minus 2. So now it makes sense now. It makes sense. So that will now become minus ln x minus 2. And what you are doing here is that you are adding plus 2 to the function. Okay, it doesn't change your form. Okay, you're adding plus 2, minus 2 to the function. It doesn't change your form. Look at the standard rule. 1 over x is what? Ln x. So whatever you are adding, you will say 1 over x plus 2. It will give you what? Ln what? X plus 2. You will say 1 over x minus 2. Okay, integral. It will give you what? Ln what? Ln x minus 2. So that's what the rules we are applying here. You're adding minus 2 to the functions. It doesn't change the form. So then plus what? Plus c. So that's that on that rule. That's that on that rule. C part. Integral of 5x plus 3 dx. Okay. Integral of this. This is very simple. This will be equal to, let's do the algebra. Now 5x plus 3 to power half. Remove the radical, and that will be, that's that. Then the next thing to do now is to do the normal integration, which will be equal to 5x plus 3. And then this will be what? Half plus 1, that's 3 over 2. And then here also, what? 3 over 2. Okay, then divided by, you have to divide by what? The attachment of that constant. Okay, attachment of that constant, to which will be equal to 1 over divided by 5. So, and this will give you, don't forget this will be equal to 5x plus 3, 3 over 2 over this one 3 over 2, and this will be equal to 1 over 5. And this one, you multiply it, that will be 15, 15 over 2. That will be 15 over 2, and that will give you the inverse of that. That's 2 over 15 into bracket 5x plus 3 over 2 plus c. So that's that on that case. So what I will recap that again. Is very simple, but care must be taken. We are multiplying here the variable by 5, and don't forget the rules. I think number 3, that we need to divide by that. We have to divide the result by by what you are using to multiply the variable. So first of all, let's get the integration, the normal procedure, which is this 1 plus 1, and then over what? Over the power, which we have done here, and then divided by what? Divided by the attachment of the variable, divided by 5. Okay, and then change this division to multiplication, that's what? 1 over 5. And then 3 over 2 times 5, that's 15 over 2. And then if there's 1 here, it's inverse, that'll be 2 over 15. To flip it upside down, and that's that on that case. D part, we have integral of 1 over 4 minus 3x dx. Okay, this one is also simple. The first thing we have to do, look at what we have here. We have, don't forget this rule. I think it's this form. Okay, don't forget that's ln x plus c. So in this case now, this is what? Can you take the minus out here, which will be dx into bracket minus, if you take minus out, you have 3x minus 4. Okay, that's what we're going to have there, which will be equal to what? We can take the minus outside, and that'll be dx all over 3x minus 4. Okay, so that's what we have done there. Then in this case now, this will be equal to minus ln 3x minus 4. But that does not stop there. You need to divide by what? By the attachment to that variable, and that would what? Over 3. That's over 3. So and your answer will be equal to what? Minus 1 over 3 ln 3x minus 4. Okay, so that's that on that question. So that's that on that question. And I want to say that this integration, we're going to make sure that we spend time and have in-depth knowledge, in-depth understanding. I'm going to break it down, explain it for you. Okay, this is the channel to be. Okay, please, if you are new, why not subscribe right now? Hit that notification bell so that as we upload, you get notified. Okay, what are you waiting for? Do it right now. Okay, so that as we upload, you get notified. Okay, we are still on integration. Join the next video on continuations of integration. Thank you.